Hello friends, welcome to our channel Programming Minds Academy. So in this lecture we are going to talk about the storage classes in C++. So what are the storage class? Storage class is nothing but the keyword which will define the scope, visibility and lifetime of a particular variable. So let's say I have a variable and I have defined that variable with the storage class. Then during the runtime of a program, according to the storage class, that particular variable will behave. So it just defines the behavior of the variable. So there are five types of storage classes. One is automatic, register, static, external, and mutable. So all these classes have a functionality which will define the behavior of the variable. So let's get started one by one. So first is automatic storage class. By default, all the variables, if you don't give a storage class, that will be an automatic storage class. The variable which is defined within the function. So this is not applicable for the global function, but the global variables, but the variables which are defined inside the functions. So a variable defined within the function or a block with the auto specifier belongs to the automatic storage class. So you can see in the example, we have variable integer I, which is defined as 2. Now, before that, we have given a keyword auto. So that is nothing but the integer variable I belongs to the auto storage class. So all the variables defined within the function or a block by default belong to the automatic storage class if no storage class is mentioned. So let's say in a function I have 4-5 variables and I haven't given the storage classes to them. So by default auto will be their storage class. Variables having automatic storage class are local to the block which they are defined in and get destroyed on exit from the block. So these storage classes or the variables will get destroyed once the function or the code exit from that particular block. Now the second is register storage class. The register specifier declares that variable is of a storage class. So variable belonging to the register storage class are local to the block which they are defined and get destroyed on exit from the block. So these are similar to that of the auto storage class. Like the one property which is similar is like they are local, means they are only valid into the functions. So whenever we define the variable as a register, it will store that variable into the register memory instead of a RAM memory. So in an example, you can see register integer I equal to 10. So we are defining variable integer I as a register so that it will store into the CPU register instead of memory. So when we use the register storage class, that variable is mostly used for the counter, which we need to accessed frequently. Now the third is static storage class. Static storage specifier gives the declared variable static storage class. Means we can just add the static keyword to the variable so that it will become a static. Static variables can be used within the function or the file. Now, unlike global variables, static variables are not visible outside their function or the file, but they maintain their value between the calls, which means, so if you define any variable as a static, till the program ends, that particular value will be there in the memory instead of getting destroyed and created every time. The static specifier has different effects upon local and global variables. So in example, you can see we have defined the variable integer I with the static. So we just have to add the static keyword at the start of the variable. Now, external storage classes. These classes can be defined by the keyword extern. The extern specifier gives the declared variable external storage class, which means we can define a variable as an external storage class by adding a keyword extern at the beginning. The principal use of extern is to specify that variable is declared within external linkage elsewhere in the program. So let's suppose I have two files, which is file 1 and file 2. So if I define some variable as extern in file 1, I can reuse that variable into file 2. So If I take an example of this variable which is present on the screen, the integer I can define that integer I in file 1 and I can use that integer I in file 2. So that is external storage classes. When the external specifier is used with the variable declaration, there is no storage is allocated to that variable, and it is assumed that variable has already been defined elsewhere in the program, which means whenever we have a storage class, we cannot initialize that external class. We need to initialize that somewhere else. So the fifth is mutable storage class. The mutable is a keyword which is used to override the constant member function. So it has a special use in a special situation. So let's say I have a constant member function in which I cannot edit the variables. So whenever I declare any variable with the keyword mutable, I can edit that variable into the constant member function. So constant member function is nothing but the read-only function, and if you want to change something into the read-only function, you have to use a mutable keyword. So the mutable member can be modified by the constant member function. So these are the storage classes which C++ have. Hope you enjoyed the video. Thank you.